Welcome everyone. A fixed point F and a fixed line are taken in a plane. Now, let us mark all points in this plane which are at equal distances from the line and the fixed point. First of all, we may think of this point which is at equal distance from the point and the line. But there are many other points also satisfying the same condition. This point is at equal distance from F and from the line. Distance to the line means automatically it is perpendicular distance to the line. Here, many more points are at equal distances from F and from the line. Mark all those points. By the time we mark all those points, we trace a shape. All these points fall on this particular shape. The set of all points in a plane that are equidistant from a fixed point and a fixed line is called a parabola. A parabola is the set of all points in a plane that are equidistant from a fixed point and from a fixed line. Here, this fixed line is called the directrix of the parabola and the fixed point is called the focus of the parabola. Also, the line drawn perpendicular to the directrix through the focus is called the axis of symmetry of the parabola. As we can notice, this parabola is symmetrical about this line, axis of symmetry. Now, the point where the axis of symmetry meets the parabola is called the vertex. Here is the vertex, point of intersection of the parabola with the axis of symmetry. Now, we're going to draw a line segment through the focus perpendicular to the axis of symmetry. This line segment is called latus rectum. Latus rectum is the line segment perpendicular to the axis of symmetry through the focus. Now, this is the tangent drawn at the vertex of the parabola. Tangent to the parabola is parallel to the directrix. Now, we derive the equation of the parabola whose focus is at a, 0 and the directrix is a line x plus a equal to 0. This line is a units on the left side of the x-axis. So this point here is minus a, 0. We can notice this origin is at equal distance from this focus and from the directrix. Hence, origin will lie on the parabola. This is the shape of the parabola, having the focus at a, 0 and having the directrix x plus a equal to 0. Now we need to find the equation of this parabola. For that, let us take a point x, y on the parabola, a representative point, an arbitrary point. Now let's see what is the condition to be satisfied by x and y to lie on this parabola. Here, P should be at equal distance from F and from the directrix. Let's draw them. These two distances must be equal. Let's observe. Here, PF should be equal to PQ. PF should be equal to PQ for this P to lie on this parabola. We will calculate both of these. What will be the length PQ? Here, from the y-axis, Q is a units away and this P, since its coordinates are x, y, its x coordinate from origin, it will be x units away to reach this point. So this distance is x. So the total distance PQ will be x plus a. This is x plus a. And PF is being calculated just by using the distance formula x minus a whole square plus y minus 0 whole square under the root. Now we will simplify this equation. Squaring both sides, we have x minus a whole square plus y square equal to x plus a whole square. Simplify further, expanding the brackets, we reach at a simple equation y square equal to 4ax. This is the condition to be satisfied by this x, y for this point P to lie on the parabola. Hence, equation of this parabola is y square is equal to 4ax. Notice that there is only one arbitrary constant present in the equation of the parabola when the parabola is a standard one, which means the focus is at a comma 0 on the x-axis and directrix is drawn parallel to the y-axis a units away at the left side of the y-axis. X plus a equal to 0. Only then the equation will be y square equal to 4ax. Here, to find the length of latus rectum, we need to find this length. Here, latus rectum is drawn through the focus. So, this point where the latus rectum meet the parabola, we are trying to find the points of intersection. X coordinate will be A for both of these points as the latus rectum is drawn perpendicular through the focus. Now we need to get the y coordinate. But we know both of these points are supposed to lie on the parabola. So this y coordinate and x coordinate should satisfy this equation of the parabola. So I'm going to put x is equal to a in the equation of the parabola. By putting x is equal to a, we have y square is equal to 4a into a, that is 4a square. Therefore, y can be 2a or minus 2a. Yes. So, these 2 points are a comma 2a and a comma minus 2a, as the y values are these two. So, the endpoints of the latus rectum are a comma 2a, a comma minus 2a. It is evident that the length of the latus rectum from this 2a to minus 2a, the total length is 4a. Now, let's do a question based on this standard equation. Find the coordinates of a focus, axis of the parabola, the equation of the directrix, and the length of latus rectum of the parabola, y square equal to 8x. Notice that y square equal to 8x is a standard equation of a parabola turning right, the one which we derived just now. So, in this equation y square equal to 8x, if you compare with the standard equation y square equal to 4ax, we notice 4a is equal to 8, hence a is equal to 2. So the focus is 2, 0, directrix is x plus 2 equal to 0, axis of symmetry x-axis, vertex the origin, length of latus rectum is equal to 4a is equal to 4 into 2, that is 8. All these parameters we have calculated of this parabola. Take another example. Y square equal to 20x. Compare it with the standard equation. Y square equal to 20x is compared with y square equal to 4ax. So we get the value of a as 5. Hence, focus is 5, 0. Here it is. Focus is farther. It was 2, 0. It is now 5, 0. Axis of symmetry is x-axis itself, because it is a standard parabola of the type y square equal to 4ax. Then equation of the directrix is x plus 5 is equal to 0. Length of latus rectum is 4a is equal to 4 into 5, that is 20. Vertex is the origin. Here we notice these two parabola. Both are coming under this standard equation. But depending upon the value of a, the parabola will be narrow or wider. The shape of the parabola changes depending upon the arbitrary constant a. Now we will take another case where y square is equal to minus 8x is used. Observe that a is coming minus 2. So the focus is on the left side of the y-axis. So the parabola should turn left. A is equal to minus 2. So the equation of the directrix will be x plus minus 2 equal to 0, which is x minus 2 equal to 0. Directrix is on the other side, just because the value of a is negative. Hence, Equation of the directrix is x plus x minus 2 equal to 0. Axis of symmetry is x-axis itself. Vertex is origin. Length of latus rectum is 8. Length is positive. Length cannot be treated as minus 8. It is 8 units. Now, go for another example in which again A is coming negative. A is minus 5. A wider parabola turning left side. Focus minus 5, 0. Axis of symmetry x-axis. Equation of the directrix x minus 5 equal to 0. Length of latus rectum 4a equal to 20. Vertex is the origin. Now, we go for next type of parabola. That is, when the focus is on the y-axis and the directrix is drawn parallel to the x-axis. If this is the way the focus and directrix are taken, then the parabola will take the shape like this, turning up. Here, the equation of the parabola also changes. Doing a very similar derivation, we have x square is equal to 4ay. Equation, x term is second degree. Again, it is based on one arbitrary constant a. To find the length of latus rectum, this time the y coordinate is used as a and calculate the x coordinate. Put y is equal to a. We get x is equal to 2a or minus 2a. So the points of intersection of the latus rectum with the parabola are minus 2a comma a and 2a comma a. So the total length will be for a. So length of latus rectum is